From the investigation 8 that you've just created and the histograms you've just looked at and the stuff you recorded, the shape of the histogram is generally systematic about the mean. As you had more data included, the more likely the histogram was symmetrical around the mean. Yes, there might be bits of spreads of data here and there, but generally the highest point was around the mean, and it was accordingly out each side. Approximately 68% of the data lies between one standard deviation below the mean and one deviation above the mean. So down on our diagram here, we've got mu, which is standing for our mean, and we've got sigma, this signal here, is our standing for standard deviation. So this point here is one standard deviation above the mean, and this obviously is going to be one standard deviation below the mean. So approximately 68% of the data lies between there and there. So that means there's 34% in here and 34% in here. Approximately 95% lies between two standard deviations above and below the mean, and 99.7% lies between three standard deviations. So if we look at the standard shape that is produced, we get this is what we call a normal distribution, this shape here. We've also called that in the past a bell curve because it looks like a bell. Some of the things we talked about bell curves, we can talk about the positive and negative skewness. What we're looking at the moment is the pure randomness of an event, and the situation set up that we're looking at random events should have a central mean and then spread out around the standard deviations either side. So a graph of normal distribution of a population with a mean, which that symbol there is mu, mu, it's a Greek letter like we've been using, and standard deviation, and that there is sigma. Standard deviation has the following features. It's symmetrical about the mean. So you can see here that we can put a mirror up here along this mean line, and it's symmetrical around that spot. It is concave, or concave down from one standard deviation to the left of the mean. So here, this bit here is concave. The way we look at concave is if we're sort of looking from this spot here, so we're looking from here, we sort of have a cave sort of shape that's going to wrap around us. And if we're looking from here, this side here is also concave. For the other values, so we're going to be down to the lower values here, that there's convex. So if we're looking from here again, that's bending it away from us. And again, with the upper levels, that's bending away from us up there. The area below the curve and the horizontal axis between mean and two standard deviations above and below. So we're now talking about this area in here and this area in here is approximately 95%. So if we look at that, 13.5 plus 34 plus 34 plus 13.5, so it's 68 plus what's 26, 27. So 68 plus 27 gives us about 95. So that's 95% of the data. And the area below the curve, three standard deviations. So this is in here and in here. That's the area below the curve between 2 and 3 standard deviation. If we add in those bits, we get 99.7% of the data. So really all the data appears here between 3 standard deviations either side of the mean. So it's a rare event to get something outside of 3 standard deviations. So that's sort of an explanation of some of the things that you found in investigation 8. The questions coming up that you're about to do use this graph here and these facts here as the core of the information you need to do. So you need to work out 3 standard deviations. Don't forget mean is mu, that sort of U shape with a long start point, and this shape here, which is sigma. So it's drawn like that, and U is drawn like that, and that's what you're going to be using in each one of these things.